Hello, my fellow YouTubers. This is Roy back again. Garage cleanup time. Completion. It's about clean as it gets. Give a shout out. Who's on board right now? Tommy. Okay. And Sunday night. Hope you guys had a good weekend. Anything you guys want to talk about? We can start off with some electrostatics. This is my coil winding machine. And I wound this guy up today. That's a pretty one. That one's 584 turns, 24 gauge, 600 kilohertz. And this is my stash right now of new and some older coils. Back to electrostatic. So, what do we have here? Plexiglass. I'll put one on each side. Just wanted to get it on the wheel. This wheel here has a good RPM about it, so let's give it a test here. All right. So, all right, so what are we doing here? You're asking me, right? All right, so this has a pulley on it. So this could be electrically driven. I like the way it's geared. It was only $43. I'm going to buy another one. And the plan here would to have one of these spinning with the other one on the opposite side and spinning. But I guess test number one is, I seen a video out there a long time ago, and I don't really believe it. It's one of those videos where you see somebody do something, and what they did was they had a stationary disc and a spinning disc, and they were getting the same all right, so we're back in action here. So anyway, there was a video out there that I seen a few years back, and to me, I didn't think it was true. And one side was stationary, the other side turned. So I was going to try that out first of all. So I'll take this one disc and we'll stick it just on here and leave it stationary. And then I'll put this close together and I'll spin this side. But you can see, I can't believe it. You know, just having a gear-driven, there's got to be 40,000, 30,000 revolutions. So break it loose. Now the machine's not even turning, just the wheels are turning. So let's talk about this. Anybody want to put some comments up? So we're talking about making electrostatic, okay? So basically, we're missing a few parts to make this happen, but we'll put in the center little electrodes, okay? So the first thing I want to do is make this stationary over here. And then we'll leave this to where it turns in on this, okay? And we're gonna, because I can't get them close together because of the rod and all that, I can probably bring it all the way up to about here, but I'm still gonna have a nut here. So to get the plates close, I'm gonna build a ring of electrodes. So where they make a connection from one to the other side. And the reason I'm even messing with this, because that video this guy made a long time ago, and I don't think you can use one stationary, but it does kind of resemblance has a resemblance of on when you were learning about electrostatics and the induction, I guess. DSL dead on. Hey, Adam. So yeah, we're talking about electrostatics and how it's going to put one plate solid, stationary, and the other one turning. Electrodes all the way around it, and the object is with a conductor moving by another conductor, electrons are going to be forced outwardly. So I'll put a collector on the outside over here, a collector on the other side of the wheel there, and I guess we'll run them to these capacitors because they're a good, great collector for static. So I'll be interested just to see if I can get this to do anything with one side being stationary, but I don't think that's going to work. So if that's the case, then I'm definitely going to have to make one turn the opposite way and the other one turn the opposite way. But on top of that, this gave me an idea as well today. Let me see. Well, I spun up that coil, but I don't really have another coil to show you. But I had the tube on here, and the tube went from here to here, and I was using this over here as a coil winder, okay? And I had my wire over here. So when I had the tube up there, I was thinking of the Wimshurst just with the tube. So if the tube had slots in it of conductive strips like this, going this way, and I had another tube next to it, or a flat surface, depends, or just electrodes of another conductor, the electrons are going to be forced out on both sides. So I don't know, just monkeying around a little bit. Hope you guys had a good weekend. Anything you guys want to talk about? Huh? Let me see here. I bought these capacitors, and they're I call them little cherry bombs, but they are 1,500 picofarads. So that's at 1.5 nanofarads at 21,000 volts. I was just building a little capacitor bank there. One thing about those, well, my pleasure. What's up, Vegas Pilot 03 in the house? So I was going back before I lost my internet connection. These are nice capacitors, stout. But the problem is, you see where both of these inputs are, the wires? Well, that gap right there represents my spark gap. So what I've learned was that I couldn't make the spark gap any wider. Yeah, internet kicked off on me again. Internet kicked off, sorry guys. So back to the capacitor. I don't know where you guys got kicked off, but the gap right here where the wires come out of this capacitor is the width of the capacitor. So when you have this in a circuit like the Tesla coil, and you're dealing with a spark gap, and I'm making the spark gap go wider with air blowing on it to make the sparks get bigger coming out of the top load. So if you go wider than this gap, then the mica between the legs, well, I guess I'm gonna have to. That's the only thing you can. I got some mica. Let's see, what do I have? Yep, right here. I got a nice sheet of mica. I don't even think. I think the way these are just so close. The other capacitors are more used for Tesla coils are like the Dobblers, and they're like shaped like a firecracker, and the wire comes out this way and goes out that way. So that's the downfall of these capacitors. But yeah, Adam said, yeah, put some mica in between them. But remember, when you're dealing with a spark gap, and if you're making the gap wider, um, if you go wider than this, then the electricity is going to want to go to the path of least resistance, and it'd be the capacitor. And when they spark like that, become the gap, they pop. In fact, I just blew like, I don't know. I think I blew like 5 or 6 of them. So we're trying these out with little different types of stuff here. I had all winter, had my bank that I was using of beer bottles. So I put all new bottles in, clean out the container. So I'm going to use some super conductive salt water, some ocean water. And one thing I found out about the ocean water, guys. Alrighty, back in action. So yeah, so capacitor bottles. So I've never thought of this, but been doing this for about 5 years now. I used to distill water, and I used to mess with a lot of alkalinity with water. And I'll tell you what, ocean water is very high alkalines, like 9.1, and very salty too. So I'm going to go down to the ocean tomorrow and get some ocean water, and we're going to use that salt water in these. So, back in action. I don't know. I'm having internet problems. You guys hear me? Don't hear me? Back to salt water and the capacitor bottles. I'm going to try that. Very super conductive ocean water, especially the Atlantic Ocean. Very salty. High content, high alkalinity, like a 9.1 alkalinity. So each one of these bottles equal 1 nanofarad. And 1 nanofarad is 1,000 picofarads. So when you're dealing with capacitance and Tesla stuff, you're usually dealing with top loads, which are dealt in picofarads. And with primary capacitance, it depends what you're dealing with, what your system you have or what you're looking to do. But in nanofarads, if you get into microfarads, you're popping out some big Tesla coils. So, and you're using a lot of good power. But anyway, I'm glad to see you guys hanging out tonight. It's nice to have the workshop cleaned out. So here we go again. Every time I walk in this thing, I'm losing my internet. Are you talking about on edge wheel? So crystalline. With the tap pulse on the wheel. So Tommy, who you chatting with? You chatting with? I wish I could see the chats. I got to figure this live out. Inside pulley from shaft to balls. Inside pulley. I don't think I'm privy to the conversation. But, yeah, so I had to clean the shop up.